Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to be just kind of an introductory, very simple video of how to handle basic circuit problems. So what we're looking at right here is we have this light bulb here that has a 10 ohm resistance. It's being ran off of this 12 volt battery. And what we're going to do here is we're going to learn how to draw the circuit diagram for it. We're going to then learn how to calculate the current and then the power output here of the battery. So first comes the discussion about currents. So this is the positive terminal of the battery, and what the positive terminal basically does is it attracts electrons, right? So electrons are attracted to the positive terminal, they're repelled by the negative terminal, and what that means is that the electron flow in the circuit is this way. Now, current, the positive current direction is defined around positive charge carriers. So even though the electrons are going in the direction shown, the positive current direction, if you will, for this problem is actually this way. Now, a very important fundamental of all circuit problems. If I were to take a current measurement here, 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 or here, you have to get the same value. It's a lot like you can think of it like a garden hose here with water running through it. Whatever the measurement is here, it's got to be the same here, here, and here. So there's only one current in this problem, a very important fundamental to realize. All right, now the circuit diagram. So the battery has a certain potential difference, and it's a DC potential, and this is the symbol for a DC potential. A lot of books, sometimes you'll see like multiple of these. I usually just draw two and call that good enough. The long side here represents the positive terminal of the battery, and then this shorter animal, this represents the negative terminal. In this example, we're going to use 12 volts as the potential difference between those terminals. Okay, now for the light bulb here, which has a 10 ohm resistance, we're going to put this symbol in its place because that is the symbol for resistance. Now I like to make my circuit diagrams kind of rectangular like this, but it doesn't matter. You can make this any shape you want. All right, that's not important at all. Now the current, again, even though we know that electrons are actually attracted to the positive terminal and repelled by the negative terminal, even though we know that, remember, current is always defined by positive charge carriers. So we imagine positive charge carriers moving in this direction. Because remember, positive charge carriers will be repelled by the positive terminal, and they'd be attracted to the negative terminal. Now, something that I like to do in these problems is I like to kind of analyze the potentials. And I usually use red for the highest potential. This stuff right here, this is all conducting material, right? This is wire, basically made of aluminum, copper, things like this, probably copper. And remember, hopefully you've seen my video on IFACS, which stands for Important Facts About Conductors. The conductor itself is an equipotential. And what that means is that this is all one potential. And I'm going to color code it in red. Now you will get a drop in potential across the resistor. On the other side of the circuit, this stuff right here is all conducting material as well. So that's another, that too is an equipotential. I'm just going to leave it all black. Now for super simple problems, color coding the potential doesn't, I think it's not super important, but when they get more complicated, I think that's a very, very good thing to do. So you'll see me do that in my videos from most of the time when dealing with circuits. Now, a very important thing to realize, see, red to black is 12 volts. And when we look right here, red to black, right, the voltage across that resistor is 12 volts. So we can apply Ohm's law to this resistor. Ohm's law, remember, is voltage equals current times resistance. And the voltage across the resistor, or light bulb, is 12 volts in this example. And the resistance is 10 ohms. Now I just made up nice, easy numbers to make the video kind of easy to follow and smooth, but it doesn't matter what these values are. Therefore, when we solve for the current, we're going to get 12 volts divided by 10 ohms, and this works out to 1.2 volts per ohm. Well, a volt per ohm is an amp, because you can even see, voltage is current times resistance. Right? So when you take voltage and divide by resistance, you end up with current. So this circuit is going to have a 1.2 amp current. And a little reminder, what is an amp? It's a coulomb per second. A very important fundamental circuits. Again, if I took a current measurement here, here, or here, it would be 1.2 amps. The current in a single loop circuit like this is the same everywhere. All right, second thing here, let's see, power. So power can be calculated a couple ways. Current squared times resistance, or current times voltage. Either of these should give us the same value. I'm going to go ahead and use the 1.2 amps squared times the resistance. Whoops, and that is in ohms. And let's see what we get. And I get 14.4 watts. Or 14.4 joules per second. I'm going to leave this as an exercise to the person watching the video to confirm. You should be able to take the current times the voltage and get the same value. So just meant to be kind of an introductory circuit, or introductory example of how to handle very simple DC circuits. I hope that this has helped. Have a great day.